Let's start our very first class regarding to the database class. In this class, we want to talk about what is the database and what are you expecting to learn throughout the whole semester. So this is actually your ultimate introduction, not only for the class, but also for the semester. So chapter 1, database and database users. This is the outline that we will take a look throughout this whole chapter, starting with what is the database for the introduction, and then let's directly look into an example to see what is it looks like for a database. After that, we want to define the characteristics of the database, why it is different from a file, what it makes a database a database. And then we want to look into the people who are using the database, developing the database, maintaining the database, and managing the database. Finally, we want to look into some advantages of using a database as well as some disadvantages. Starting with the database introduction. Database is involved like everywhere right now in our world because computer is everywhere now. It does not have a long history that everybody has a computer, but once the computer is there, people realize how convenient it is. So think about this. You go to a bank, this is something that manages your money. So if you go to Bank of America, you plug in your BOA card, they will try to find your identity, find your information, so that you will be able to deposit, withdraw, or even make a loan with the company. Hotel reservation and airline reservation. I believe everybody has used something like Expedia or American airline kind of website. Think about this, how amazing that is using Expedia as an example. You look for a hotel in Chicago. Thousands of hotels come out at the same time, tell you what's their price, what kind of amenities that they have. More importantly, saying that if you have only one room left of your choice, and there are two people are looking at the hotel, try to make their reservation, how would you control what we call a concurrency control? Which means one person booked it, the other person will get an error message indicating, sorry, the hotel is booked. If you go into a movie theater, you will be able to stay in the line purchasing the tickets for your movie. Not only what show are you going to watch in, but also the seats that you are going to reserve for. For the daily grocery supermarket shoppings, you go in the line, scan the barcode, no matter you have the clerk to help you or you do the self-checkout. You scan the barcode, the computer system will realize the stock information of the whole supermarket. They are all examples of using the database. All of these that I showed in this slide are considered as traditional database already. There's a lot of more advanced or newer database types that we are using all the time as well. For example, YouTube's. What is the database for? It's a database for videos. iTunes is a database for musics. GIS, Geographic Information System. This is also another very hot topic that we have in these days. Thinking about if you go to Google Map, everybody use Google Map. You will be able to find a location, say in New York. As soon as you hit the direction, in seconds, probably 1 or 2 seconds, and that also contains the traffic operation time. It will be able to direct you from Arkansas to New York directly, tells you what is the best route as well as what's the traffic conditions that you have. Think how amazing it is and how fast it is. They are all advanced database systems that we use in our daily life. Not to mention you can save your favorite restaurants. You can mark the national parks that you want to go to. They are fantastic database systems in real life applications. Some more advanced stuff for data warehouses that's going to relate it to the next topic after you study the database, which is about data mining. What kind of information that you can find, you can collect from a large amount of data. And there's many other applications that you can see in the database systems. And therefore, these are the examples of extraordinary database that we use in our daily life. Of course, this is going to be your first database class or database materials that you have learned. So we will focus on the traditional materials first, so that we will be able to understand what is a database looks like. Database can be any size and any complexity. It can be as simple as an address book that you store or a phone book that you store in your phone. Right now, probably no one remembers other friends' telephone number anymore because they are all stored in your cell phone. But that is the small database that you can consider. It can store the people's name, it can store their telephone number, maybe email address, maybe office line, etc. A bigger database example is IRS. Probably everybody pays tax, and you know how it looks like when it comes to the tax season. You need to prepare multiple page of the information sent over to the IRS using your social security number as the key attribute that identifies every individuals in the IRS system. Assuming that it has 100 million taxpayers, and of course that's underestimated, and each taxpayer only file 5 forms with 400 characters of the information, and basically that's as big as 800 gigabytes already. And people has usually more forms, and of course we have more peoples that making the text files. Thinking about Amazon, how big it is and how fast it has grown. 15 million people visit per day, and about 100 people are responsible for database update. So this is also another amazing usage of the database. So what is a database? A database, starting with the data. So database is a collection of the related data. So they will collect all of the informations that fits into the theme that database try to capture. If that's IRS, then taxpayers' information is the related data. For Amazon's customers as well as the products are the informations that Amazon want to capture. So data are the known facts that can be recorded by computer. This is very important. Computer only understands 0 and 1s. However, it can, as you already know, can store a lot of different things based on simply 0 and 1 stuff. Data, names, numbers, prices, videos, musics, etc. All of these can be recorded. So those are data the database want to keep track of. However, if you only have the data and if you only put them together without a system, without a programming system to help you process those data, it will not be easy. You still need to use manual search, finding the information that you need. And therefore, not only the data creates the database, you also need a database management system, DBMS, a database management system to help you define the database, construct the database, manipulate, which means that you can search, insert, delete, those kind of operations, just like you have learned the hash table topics in your data structure class, and share functions of the computerized database. So if you understand correctly, this class that you are taking is CACI3360. That name is database systems. So a database system is basically you need to use your DBMS, which help you to define a database. So you define a particular database in terms of its data types, structures, and constraints. Construct or load the data into the database. and then you will be able to manipulate the database, including retrieval. That's basically like search operations that you have, modification, insert, delete, and updates of the contents, accessing the database through the web applications. This obviously is the main thing in the DBMS system. Of course, you also need to share a database, allow multiple users to use it. Everyone has different user ID, have different privileges that you can see in the database. So the database management system need to handle all of this, and therefore, for this class, what you are going to learn not only the database but also the DBMS, database management system, to work together seamlessly with the database to form a database system. So this is what we are expecting to learn in this class. This picture gives you an idea of how does the database work together with the DBMS, so that it can provide the information to the people who are going to use it. Therefore, let's take a look of this picture. This is the picture that tells you DBMS software is in between. So you can see that this is the DBMS package that you're going to use to manage your database. In this class, we are going to use Oracle as the DBMS software here. So what we're going to learn is how do we use Oracle to construct a database, to load a database, to create a database, and to use a database. To feed into the DBMS system, you need to have the data being stored. So you have a database over here, but data being stored in the database requires the structure. And therefore, what is that structure looks like defines in this box, what we call the metadata. So it's stored database definition. You need to combine the two things, combines the definition of the database with the data that's stored inside the database to be able to let DBMS retrieve the information out of it. An important idea, what we call the metadata here, the definition of metadata is data about data. Let's take a look of an example. A university example, since you guys are already in UCA and you're using UCA.com to manage a lot of different things, including you try to look into your transcript, you try to sign up some courses, you want to drop some courses. So let's take a look of this as a simple example. A university database for maintaining information concerning student, courses, grades in university environment. So saying that we have 5 different tables over here. Starting with the student table, it stores the information about the student, about the course, like CS4320 database course. Course file stores data of each course. Sometimes one course has multiple sections, just like database class. It has 1, 2, 3, maybe even more different sections associated with the different courses. Based on that, you also need to report for the students who are taking what course section to get a score or the grade in the end of the semester. Of course, some courses has prerequisite, and that is also another table stores that kind of information. So if we go into the next slide, you see that this is a database consists of 5 different tables. Saying that, let's try to understand this database. Student, we have 2 students. Say we just started a university, and that's why we only have 2 students. We have their name, we have their student number indicating that uniquely which students are we looking at. Class, major, so these are the basic information about the student. If we look into the courses, indicating that there are 4 courses, 6 in this database. They are Introduction to Computer Science, Data Structure, Discrete Math, as well as the database. The next table, section. For humans, we actually can understand what does this mean. So if we look into the very first section, section identifier, 85, okay? And it is associated with Math 2410. Immediately, you will reference the previous table to see that CS4420 math is actually a discrete math class, so that you form some linkages between this table with that table. You also have other section identifiers. Basically, these are like your CRN number. Math has two sections. In this case, Math 2410 has one section identifier as 85, the other one is 112. So you see that that is the association between these two tables. The next one is actually even more interesting. Try to take a look of this one and guess what is the first row try to represent in the grade report. Student number 17, that means Smith. Section identifier 112, that means math class that this Smith is taking, and he get a grade of B. Therefore, you can see that this is the table that links not only one table but two, and among those, section 112 can go further back to the course section to find which course, the name of the course that Smith is taking. So they are all closely related. Obviously, there are some structures in between these 5 tables. Not to mention, each table need to define their information by what are the column name, what are the data that you want to store in each column, and what's the primary key or the most important attribute it is in each table. There's obviously a lot of different things that you need to be stored. So, database manipulation involving query and updating. So what is a query? Query means that you want to retrieve a transcript of a person. So take a look of this one. Say that I am Smith and I want to find out my transcript. So what is happening here? You basically need to go to the grade reporting, output everything that associate with my student ID 17, and then probably even generate a GPA based on what you have over here. That is a query information. Try to look into the information that you have stored in your database. Of course, updating. Another example is that Smith is going to take a new course. So we need to create a new tuple or new row in the grade report saying that that person is taking this course. At the time, maybe when he just signed up the course, the row has been created, but the grade value has not been put it over there. And only when the semester is over, the instructor provides a final grade to this student, when we then update the information over there. So this is the idea of the database manipulation.